Generative AI has emerged as a transformative force in artificial intelligence. It empowers computers to create new content, from text and images to music and code. This capability distinguishes it from traditional AI systems that primarily analyze existing data. Generative AI opens up exciting possibilities for innovation across diverse industries. Its impact is already being felt in areas like content creation, drug discovery, and software development. Imagine a world where AI can generate marketing copy, compose music, or design new products. This technology can significantly enhance productivity and efficiency. The rise of generative AI is driven by advancements in deep learning, particularly in sophisticated neural network architectures. These architectures enable AI models to learn complex patterns and structures from massive datasets. Understanding its underlying principles and potential is crucial for navigating the future of technology. Machine learning is the cornerstone of generative AI. It focuses on enabling computers to learn from data without explicit programming. Instead of relying on predefined rules, machine learning algorithms identify patterns within data to make predictions or decisions. These algorithms can be categorized into supervised learning, unsupervised learning, and reinforcement learning. Neural networks, a key component of deep learning, are inspired by the structure and function of the human brain. They consist of interconnected nodes or neurons organized in layers. The learning process involves adjusting the weights and biases of the connections between neurons. This iterative process allows the network to gradually improve its performance over time. The ability to learn from data and adapt to new information is a key strength of neural networks. Neural networks are the fundamental building blocks of many advanced AI systems, including generative models like ChatGPT. These networks are composed of interconnected nodes or neurons organized in layers. Each connection between neurons has an associated weight, which determines the strength of the connection. The simplest type of neural network is the perceptron, which consists of a single layer of neurons. For more complex tasks, multi-layer perceptrons, or MLPs, are used. Convolutional neural networks, or CNNs, are designed for processing grid-like data, such as images. CNNs use convolutional layers to extract features from the input data. Recurrent neural networks, or RNNs, are designed to process sequential data, such as text or time series. RNNs have a recurrent connection, which allows them to maintain a hidden state that captures information from previous time steps. Long short-term memory, or LSTM, networks are a type of RNN that address the vanishing gradient problem. GPT, or Generative Pre-trained Transformer, has revolutionized natural language processing. It is based on the transformer architecture, which relies heavily on the mechanism of attention. Attention allows the model to focus on different parts of the input sequence when generating output. The GPT architecture is characterized by its depth and the massive amount of data it is trained on. These models are pre-trained on a vast corpus of text data, followed by fine-tuning on specific tasks. One key innovation is its ability to process input sequences in parallel, unlike traditional recurrent networks. GPT models have demonstrated remarkable capabilities in generating human-quality text. The continued development of GPT models is pushing the boundaries of what is possible with natural language processing. Data collection is the foundational step in building a generative AI model. The quality and quantity of data directly impact the model's performance. The data should be representative of the task the model is intended for. Identifying relevant data sources is crucial. It's essential to ensure that the data you collect is ethically sourced and respects privacy regulations. Once you've identified your data sources, the next step is to collect the data. This process might involve web scraping, using APIs, or downloading publicly available datasets. It's important to have a robust data collection pipeline that can handle large volumes of data efficiently. The collected data should be stored in a format that is easily accessible and manageable. Proper data management practices are essential for maintaining data integrity and facilitating collaboration among team members. Data preprocessing is a crucial step in preparing the collected data for model training. Raw data is often noisy, inconsistent, and incomplete. Preprocessing involves cleaning, transforming, and preparing the data to make it suitable for the AI model. Cleaning the data involves handling missing values, removing duplicates, and correcting errors. Transforming the data involves converting it into a format that the AI model can understand. This might involve tokenization, stemming, and lemmatization for text data. For numerical data, it might involve normalization or standardization. Data augmentation techniques can be used to increase the size and diversity of the training data. This can involve techniques like data synthesis, which involves creating new data points from existing ones. By creating variations of existing data, the model can learn to handle a wider range of inputs. Model training is the core process of building a generative AI model. It involves feeding the pre-processed data to the chosen neural network architecture and adjusting the model's parameters to minimize a loss function. The goal of training is to find the optimal set of parameters that minimize this loss function. The training process typically involves iteratively processing the data in batches. Each batch is fed through the network, and the loss is calculated. The model's parameters are then updated using an optimization algorithm such as gradient descent. Hyperparameter tuning is a crucial aspect of model training. Finding the optimal set of hyperparameters is essential for achieving good model performance. Monitoring the training process is essential for ensuring the model is learning effectively. Techniques like regularization and early stopping can be used to mitigate overfitting and improve the model's generalization ability. Evaluating model performance is crucial for assessing the effectiveness of the trained generative AI model. This involves using appropriate metrics to quantify how well the model generates desired outputs. Different metrics are used depending on the specific task. The evaluation process typically involves using a held-out dataset that was not used during training. This dataset, often called the test set, is used to evaluate the model's performance on unseen data. In addition to quantitative metrics, qualitative evaluation is also important. This involves human evaluation of the generated outputs. Human evaluators can assess aspects of the output that are difficult to capture with automated metrics such as creativity, fluency, and coherence. Visualizing the model's outputs can also be helpful for understanding its behavior. Visualization techniques can help identify areas where the model is performing well and areas where it needs improvement. Building and training generative AI models requires significant computational resources. The hardware requirements depend on the complexity of the model and the size of the dataset. Training large language models like GPT-3 requires powerful GPUs or TPUs. Choosing the right software framework is essential for efficient model development. Popular deep learning frameworks like TensorFlow and PyTorch provide a rich set of tools and libraries for building and training neural networks. Cloud computing platforms like AWS, Google Cloud, and Azure offer access to powerful hardware and software resources for AI development. These platforms provide pre-configured environments for deep learning, making it easier to get started with model training. Data storage and management are also important considerations. Large datasets require efficient storage solutions. Proper data management practices are crucial for ensuring data integrity and facilitating collaboration among team members. Generative AI has a wide range of potential applications across various industries. In content creation, it can be used to generate marketing copy, write articles, and create scripts. In drug discovery, it can be used to design new molecules and predict their properties. In software development, it can be used to generate code and automate testing. However, the development and deployment of generative AI also raise important ethical considerations. One key concern is the potential for misuse of the technology. Generative models can be used to create deep fakes, which are realistic but fabricated videos or audio recordings. Another ethical concern is bias in data and models. If the training data reflects existing societal biases, the generated outputs may perpetuate or even amplify these biases. Ensuring responsible development and deployment of generative AI requires careful consideration of these ethical implications.